Now what is the magnification produced? The magnification produced is the product of the magnification produced by the first refracting surface multiplied with the magnification produced by the second refracting surface. Now what is the magnification produced by the first refracting surface? It's Vi by mu u mod. By the second refracting surface, V by mu is 1 by mu in this case into the image location was Vi. So you see that I get the final magnification as V by u. Okay, so this is the magnification produced in case of a thin lens. Now if you look clearly in this equation, you see that mu minus 1 into 1 by r1 minus 1 by r2 is equal to 1 by f of the lens. Or I can write focal length of the lens mu minus 1 is equal to r1 r2 divided by r1 plus r2, right? That means what? F lens, what is mu? Mu is the mu of the lens divided by mu of the surrounding is equal to r1 r2 by r1 plus r2. For a given lens, the radius of curvature is constant, so this is a constant. That means this is a constant for a given lens. Now, depending upon R1 and R2, you have several kinds of lenses. For example, we have two refracting surfaces, right, in case of thin lenses. Now, each of the two surfaces, these two surfaces can be either convex, concave or plane. Similarly, this surface could be also convex, concave and plane. Now, you can choose one from this and you can choose one from this. Okay, so how many cases you'll get? You'll get 9 cases. So there are total of 9 types of lenses possible. A very simple example or a very straightforward example of two combinations will be when you take plane and plane. When you take plane and plane, you get a thin glass slab. Now, the other two cases is when you take convex convex or you take concave concave. A convex convex lens looks like this. Both the refracting surfaces are convex. Or it's a biconvex lens. Now, what is the focal length of a biconvex lens? I mean the sine. I want to know the sine of the focal length of a biconvex lens. This is equal to 1 by f, you know. So I want to know the sine of f. You see that for a biconvex lens, if I have an object here, the refracted ray will lie in this medium. So R1 will form an image here and R2 will, let's say, form an image here. This is the intermediate image and this is the final image. So R1 is a positive quantity because R1 lies in the real space, and for the second refraction R2 is a negative quantity because R2 lies this side. So you have something like positive minus this, so which means you have a final positive quantity. That means the focal length of a biconvex lens is always positive. Similarly, if you take the example of a biconcave lens, both the surfaces are concave, then what happens? You write mu minus 1 by r1 minus 1 by r2. This is equal to 1 by the focal length of the lens. You see, in this case, if I have an object here, r1 is in this side, r2 is in this side, somewhere here. For the first refracting surface, this is my virtual space, this is my real space. So r1 is a negative quantity because it lies in the virtual space. For this refraction, r2 is a positive quantity because it lies in the real space. So I have minus, negative, minus of a positive quantity. So the whole thing is a negative quantity, which means the focal length of a biconvex lens is always negative. Okay, now let's take few examples. The first example is as follows. The first example, we have two convex lenses L1 and L2 having focal length 30 centimeter and 60 centimeter. These two convex lenses are 90 centimeter apart. Now a plane mirror is placed (90 centimeter) from L2, and the object is 45 centimeter from L1. So the question is, find the distance of object from the final image. So the question is, find the distance between the object and the image. So if you draw the diagram will look something like this. You have two convex lenses and a plane mirror. This is L1 and this is L2. This has a focal length of 30 centimeter. This has a focal length of 60 centimeter. This distance is 90 and this distance is also 90. It's given here. Object is placed 45 centimeter from this. Now you are asked to find the distance between the object and the image. So let's see where the image is formed.